Hello again and welcome to the first keynote session we have at PIMRC. We have a great pleasure to have Peter Vetter from Nokia Bell Labs as our first speaker. Dr. Vetter is president of Bell Labs Core Research and he is also Bell Labs Fellow. Peter received a degree of physics engineering from Kent University, Belgium in 1986 and PhD in 91. Since 2009 he has worked at Bell Labs Murray Hill, New Jersey and has been on the senior leadership team of Bell Labs since 2013. So this session and like other keynotes are organized in such a way that we have recorded videos first, and after that we have live Q&A session where the actual speakers are present, and maybe I can welcome Peter to say some welcome words to start with.
Hi Matti, good day everyone, and thanks for having me. I look forward to your questions after the recording of my presentation. Yeah, thanks for having me, and hi everyone. I want to share with you our vision on, which is a vision that we already presented at several events, and where we already see in the industry a consensus of what 6G is going to be, a direction with all its uncertainties, and an agreement that, yeah, it will be still a decade out before we see that commercial deployment by 2030. So therefore, today I wanted to give also a bit an additional perspective of what innovations we still can expect from 5G Advanced in this decade, and how 5G Advanced is actually an important stepping stone for some of the capabilities that we want to enable at a larger scale in 6G. So here is the vision of augmented human in the 6G era. And as we've presented in previous conferences, we very much see a connection of the physical world and our own biological world, thanks to the massive scale deployment of sensors and AI/ML with digital twin models in the digital world and real-time synchronous updates. And these digital twin models are very important because they allow us to analyze what's happening in the physical world, simulate possible outcomes and anticipate needs, and then take productive actions back into the physical world. And in order to make that vision happen of the augmented human in the 6G era, we say there is an important new infrastructure, the 6G infrastructure that has 6 technology innovation areas that we need to work on in the coming decade. And everybody in the industry seems to agree on the high level areas, and everybody seems to agree that there are 6 of them, even though some of the areas are slightly differently defined. There's clearly new architecture paradigm shift with the cloudification of network functions. There's the increasing use of AI/ML in new ways to orchestrate and automate a network. Then there's new spectrum technologies in existing spectrum and new spectrum going even into terahertz, not only for communication, but then also for using the ubiquitous radio also for sensing. And then this all needs to happen with an increased level of security and trust, enabling these new architectures with extreme connectivity. While we're having that 6G research already going, and it's important that we have that to be ready by 2030, we still expect a lot of innovations in 5G Advanced. And also 5G had at the start this iconic representation at the time of a triangle with the 3 corners, the enhanced mobile broadband use cases, the automation use cases enabled by URLLC or ultra reliable low latency communication, and then the massive machine type of communications. And this pretty much defined the work that we did in 5G in the release 15, the release 16, the release 17. So, but there's still a lot of innovations to come in 5G Advanced for the subsequent releases, and we can expect them more at a cross-section of these corners. So as an example, enhanced mobile broadband combined with lower latency and enhanced reliability will improve the experience, for instance, of real-time video communications, real-time holographic experiences, or actually also digital twin models updated in real time through real deployment of video sensors. The second dimension is also expanding the capabilities for the verticals. So URLRC as the basic functionality and massive machine type of communication, but then actually at the combination also enabling more precise timing and more precise localization to enhance vertical use cases. And then on the third side, we see the extension of the coverage, enabling enhanced mobile broadband as well as the massive machine type of communication across rural areas, across ocean liners, offshore air corridors, enabled by not only terrestrial but non-terrestrial network technologies. So these innovations in 5G Advanced will be important, and every keynote nowadays needs to talk about COVID. So I'll also inject a perspective how COVID, I almost typed here, infected 5G. What we have seen is in the early days of COVID, how it accelerated the e-commerce. It really spiked within 6 months, an evolution that otherwise would have taken 6 years. And this, however, was only possible because there was an infrastructure in place that took a decade to roll out. And yes, at the start of COVID, we had some scaling problems with the servers, some Zoom sessions and so, but we fixed for that. The basic infrastructure was there. And it is this realization that this ICT technology is so important to keep our economy going in times of a pandemic. And it's also the realization in the new normal that increased levels of automation, increased abilities to do remote control and of processes will become very important. So we predict an increased and an accelerated investment in 5G enabled ICT technologies. So let me explain that a bit more in the following slides. So there's actually two industries that we can distinguish. There are the digital industries, think e-commerce, think banking, the digital mature industries that are only 1/3 of our economy, but they have 70% of the ICT investments. And then there are the physical industries, think mining, think agriculture, think retail, transportation. They are the largest part of our economy, 2/3, but only 1/3 or better, 30% of the ICT investments. And it is these digital industries that have a healthy productivity growth year over year of almost 3%, while these physical industries are at a sub 1% productivity growth year over year. And the whole idea of the Industry 4.0, the industrial automation enabled by 5G is to bring the digital technologies to these physical industries to also there achieve higher productivity growth. Now, what will happen with the accelerated investment? You see here, the red curve is what I've already shown you, the investments that have been done to roll out the e-commerce, digital mature economies. What my colleagues of Bell Labs Consulting have analyzed is that also in the physical leading industry, we will see an acceleration. So you see that by the purple curve and the inflection point, the purple dot, will be now, after the insights that we have with COVID, accelerated by 3 years. So think physical leading industries as retail, transportation, manufacturing. And to illustrate that a bit better, let's take the example of Amazon. Amazon, on one hand, is a digital mature company in sense of e-commerce, but you can also think of them as a physical industries, and they are leading the pack with the retail and how they're automating their warehouse processes, how they're automating their deliveries. So these are the physical leading industries, but also the physical industries that are lagging. Think mining, think agriculture. Also, they will see an acceleration with the inflection point already happening in this decade. And so by the end of this decade, what we will see is an inversion of the ICT investments. And we see that actually the physical industries will now represent 65%, or actually more proportion to their real size in the economy. And we're talking the numbers. So here the analysis, we're talking about by 2030, the ICT spend will be $4.5 trillion, or 75% of the total ICT spend. And what we call here 5G enabled ICT is those kind of ICT applications enabled by 5G connectivity, 5G slicing, 5G security, 5G private networks. But the investments are larger than just the 5G technology. It's also then the cloud applications, the private network, enterprise applications that are enabled with it, or also the AI, ML enabled applications thanks to the massive connectivity of sensor data that is then fed into these AI, ML services. And yes, basic connectivity is an important part as well, 13%. 4.5 trillion investment in 5G enabled ICT. So an important part of investment that still will happen in this. And what are we driving here? We're going obviously for better productivity, but it's actually also better efficiency and better safety. And yeah, we sometimes obsess with triangles, right? We represent that here also in a triangle. So the productivity is do more with the same. So better output for a factory floor with a set of human resources, with the material, raw material inputs, or also agriculture surface area. Efficiency is then more do the same with less, and you could say, yeah, is that the same? But there the emphasis is more reduce the amount of waste. Do it with less energy. Do it in a more sustainable way. Reduce the scrap. Enhance the quality. And then safety is do no harm. So reduce the number of injuries, the number of accidents in your manufacturing process, or also exposure to hazardous materials to the employees, or also at large to the environment. And Bell Labs Consulting has done an analysis, and here is a high-level summary of some of these analyses, how collaborative robots, by taking out the human out of the loop, to improve the safety. And because, yeah, robots are not unionized, they enhance the productivity, but also the efficiency and the usage of the assets. Similarly, you can think of the video sensors. They monitor the hazardous workspace, they anticipate potential dangerous situations and prevent accidents by raising an alarm in time, or stopping the operation of machines or vehicles. And at the same time, video, to go to the other side, helps with inspection of quality, reducing the scrap, and taking human error out of the loop. And then on the last line, automated vehicles, you can again understand how that helps reduce the number of accidents, how that also, by optimizing the milk run, for instance, in a warehouse, that you can enhance the productivity and the lead through, and how that also reduces energy consumption. So we are actually flying our own jets in Nokia, and unfortunately this is still a virtual event. It is hosted by Oulu University, and so use a bit your imagination when I say here in this city, in Oulu, we have actually our Nokia conscious factory. And in this factory, we're manufacturing our radio system, and we apply all of these 5G enabled automation solutions. And you see in the video that there are humans, but these humans are not doing the mundane manual task or mundane clerical task. They are there for the more creative process optimizations and efficiency improvements. And so what we achieve in this factory is improving the safety, improving the productivity, and improving the efficiency, all enabled by 5G. So we're applying an edge cloud in which we keep the state of the factory, from which we run the control, massive scale sensing to update the state of the factory, and then 5G also for the connectivity of the robots over a private wireless network. And so the numbers speak for themselves. We have been able to improve the total lead time by 80%. The year-over-year productivity, we were able, by applying this technology, to improve by 30%. And then by taking the humans out and automating the quality inspection through video, through augmented intelligence, we reduced the number of defects by 50%. So an important improvement of the efficiencies and productivity thanks to the use of 5G ICT-enabled technologies. So we're actually already using the model of digital twins with 5G. What we can expect in 6G is using these kind of technologies with digital twin at a much larger scale, both for thanks to the massive scale deployment of sensors and the massive scale deployment of intelligence, not only in factories, but also in the wide area networks, in cities, and even digital twins of humans. And that will have an important impact on the network architecture. And you see here the view of that network architecture. So you recognize on the left-hand side the consumer home, the residential, and then the mobile network and the enterprise network, and then the access network, the anyhall, the cloud, where we embed the different functionalities of cloud control, network functionalities, storage, AI, ML, and also the radio technologies, and then the IP optical transport network that connects that with the central cloud. And so what we expect, because of these new applications, is a massive scale deployment of sensors, is enormous increase of upstream traffic to these digital intelligence, digital twins that are distributed over that infrastructure. And so think of these digital twin representations as real-time updates of a 3D model with then layers of parametric information. But you can also think of these models as more abstract, self-learned AI models. And then you update across the network these models and the weight factors in real time. So a very different type of traffic and utilization of the network in 6G. And that will then allow us, as already explained, will augment our human capabilities and our human productivity. So it enhances our proximity. We will be able to capture the world at a distance, to represent that world again at a distance. Models, a digital twin model of myself in real time can be transported over the network so that I can be there with you as if I were there in a holographic representation. It can also be looking at a digital representation of a joint collaborative work item. And then it's also about enhancing the intelligence, understanding what is happening in the world, anticipating needs, and then planning for the most optimal outcomes, taking actions back into the physical world, and also digital engines to augment our safety, our productivity, and our efficiency. And we offload humans for what machines can do better in terms of safety, productivity, and efficiency, but then also augment humans to do what humans are really good at. And that is learning more complex problem situations, solving them in creative ways, or also caring for each other. So things that we also love to do and enjoy more. To make that future happen, we will need a new fabric, and to make that happen at scale, which we call the 6G network infrastructure, and we have identified those 6 research vectors that will cause this disruption for 6G. But the point I want to make here in this presentation, that is each one of these areas will already have early precursors in 5G and in 5G advanced. And there will be important evolutions that we can ride on in terms of network waves, as I will show you here in the coming decade. So first is the system performance network wave. And this is a wave that we've been riding already for several decades, improving the performance of the radio interface, improving the performance of the network fabric, optical, the IP routing, and doing this at higher speeds, lower latency, lower energy consumption, lower cost. And that will continue to work. The second wave that we see now as an important paradigm shift in this decade is the cloudification of network functions, which will bring a wave of software agility. And we've seen that in 5G very clearly with 5G core. And we see also how that is happening for 5G RAN. And that will bring us a new level of dynamicity, a new level of scaling functionality and agility. And it is also an enabler for new deployment models, just like with cloud applications, which we increasingly run as a service. Actually, now the network becomes a part of that cloud integrated network, and also the network we can start deploying as a service. So that is an important third wave that we will see as a consequence of that software agility. And it will become important then that you have the proper interfaces to expose the network capabilities to the applications and the application developers, and to also have the proper translations of intent from the application into something that the network can understand. So talking about the network architecture, let me zoom in on that cloudification. So we have already seen on the right-hand side the cloudification of the 5G core. And we see the start of cloudification of the RAN with the virtualization of the RAN. And you see here how that happens on a distributed cloud, the on-prem cloud, the far edge cloud, the edge cloud, which in each of these locations not only the general purpose CPU, but in increasing level also AI/ML accelerators and GPUs, graphical processing engines. And these graphical processing engines are important compute engines that also can do signal processing. And so at Bell Labs, we have actually built a virtualized RAN completely with high throughput, using the GPU capabilities. And in future, we can expect the next level of efficiency improvement with even more specialized signal processing designed in a data center fashion with RAN NIC cards in a cloud native design. And having that cloud native approach then allows you to, in a true flexible way, instantiate RAN functions like a distribution unit or a centralized unit and optimize them on a slice by slice basis, scale them and select them the best location for the low latency slice on premise, or for the high bandwidth slice, you do it in a location where you can optimize for throughput with a larger pool of processing resources and do pooling. This will already happen in 5G, in 5G Advanced. And what we are saying now is that this is actually an important paradigm shift, this disaggregation for 6G. And we will see these microservices will allow for even a next level of architecture optimization with the RAN core convergence, where we have a fresh look at the functionality of RAN and core and optimize these functions, look at the redundancies, and then also have more specialized functions. So not only scaling the function, but actually have specialized functions tailored to the need of the slice. So with with this cloudified network functionality, just scratching the surface of the new architectures that 6G can bring to us. Looking at it a bit more broader, 6G architecture has many dimensions. I already spoke about the heterogeneous cloud of private cloud, on-premise, far edge and central cloud, the web scalers, then also the RAN core convergence, and then the automated deployment of that thanks to cognitive technologies, and I'll speak to that a little bit more in a minute, the automated orchestration and management. And then all this is driven by data. And then we also need a architecture that properly stores and makes these data available to the network capabilities as well as to potential applications. So how do we manage these data lakes? How do we then, as another theme, do the slicing, the deep slicing, new network architectures with subnetworks, and I'll say a bit more about that in a later slide, and then also new radio access network technology architectures with cell-less approaches. Already in 5G Advanced, we can see how AI starts being introduced in many parts of the network at many layers in many functions, be it for the optimization of beamforming at the radio layer, the scheduling at the cell side, or then also in self-optimizing network, all using AI. Just zooming in a bit more at the layer one, the physical layer, what we're trying to achieve is a better performance at lower complexity for the communication between a point A and a point B. And for that, we have come up with the well-known models of transmitter and receiver, with the front end, modulation, demodulation, error, and coding and decoding, and then also the medium access. And already in 5G Advanced, we start using AI ML to further optimize each of these layers separately. What we can expect for 6G is a clean slate approach, where we do away with the complexity of these layers and where we just let AI ML figure out in real time how to best communicate between two endpoints. And this will further enhance the performance, because at every interface of these different layers you lose information, but it is mainly also lowering the complexity, a new paradigm shift also in the way we design networks, and it may also have an important impact on how we standardize networks. At Bell Labs, we already started doing this research. Here is an example how we let AI/ML figure out the best constellation depending on the channel conditions, as an example. So AI, native AI and ML air interfaces. And another important innovation is then enabling further capabilities for vertical applications, already in 5G Advanced. So the baseline is set with URLLC, ultra reliable, low latency, but in 5G Advanced we can expect even more precise timing and synchronization, more reliable synchronization, so especially in applications where there's reliability problems with access to synchronization from satellites, doing that with extreme precision, for instance, for power grids, for instance, for banking, or also in reliable synchronization in indoor applications. The other important application is the sidelink, where extensions, where we enhance the latency and the reliability by using path diversity. And here in the diagram, you can see how we use path diversity to enhance the connectivity, the reliability of the connectivity in a factory with different robots through device-to-device communication. And in this way, lower the cost of the radio deployment, because we need fewer cell sites to achieve the same reliability. Similarly, also for vehicle-to-X, vehicle-to-vehicle communication, low latency, higher reliability. And then also enhancing further the capabilities of red cap, reduced capabilities. We initially talked about this as new radio light. And so this is the machine type of communication with UEs that have reduced complexity, reduced cost, and reduced power consumption. So this is for the vertical enterprise applications in the 5G era. In the 6G era, we can expect specialized use cases with even more extreme network requirements. Think of networks with specific requirements in subnetworks. Think of the network of networks where the endpoint is again a network, a machine area network, a car area network, a body area network. And within that machine area network, that can be a complex roll-to-roll machine with hundreds of sensors over an area of less than 100 meters. Well, these sensors need to communicate within 100 microseconds with extreme high reliability for the operation of that machine system. Similarly, in a car, the brake connected now wirelessly, you don't want that brake to fail ever. So not 5.9 reliability, but 9.9 reliability. So extreme specialized network requirements in subnetworks. Staying with the theme of verticals, it's not only about precise timing, it is also about more precise localization that, again, already will be enabled in 5G. 5G advanced, again, more in the indoor where we don't have access to satellite localization capabilities. And you see here a prototype that we are testing in an experimental factory in Arena 2036 in Stuttgart. And you see how we are able with 5G to track the location of the robot. You see the green dots on the map with 10 centimeter accuracy. All that thanks to 5G localization, time of arrival combined with angle of arrival. But moving to 6G, we can take that to the next level. We can use the 6G not only just for localization, but also as a sensor. And the radio is ubiquitously available, so we can use it to do radar, discern volumetric information with high accuracy thanks to use of wide spectrum and new spectral ranges all the way up to terahertz. But then not only volumetric information, but also material specific properties. Are we dealing with a metal surface? Are we dealing with a body that contains water? Is it a human or a mammal? So combine this information with AI/ML, and there's a lot of new insights that we can get from the physical world, and that's why we call that the 6G network with a sixth sense. Also, do things that a camera cannot do. Non-line of sight. Use the reflections from walls to look around the corner. So localization. So, but that is enabled by radio technologies, and there is the more mundane part of increasing just radio capacity by enhancing the spectral efficiency. And still in 5G, we can expect further improvement of the efficiency with extreme massive MIMO. And as we all know, there's different instantiations, different solutions in massive MIMO that give us better bits per second per hertz performance, starting with the grid of beams, where the UE connects to an existing grid of beams. The more sophisticated implementation that we see today is an eigen beamforming, where the beam follows the device. But you still have those side lobes that actually cause crosstalk potentially to other devices. So the next level that we already have the solutions for, but we still see the rollout in products is the zero forcing, where you zero forcing, as the word says, where you force the crosstalk of that side lobe away, where you steer a null in the direction of the other devices. And then the next level of efficiency improvement is to reduce multiple panels and do a distributed massive MIMO with combinations of beams. Now, unfortunately, these different levels come with an increase of complexity, orders of magnitude increase of complexity, and that's why this is so prohibitive, and that most of the deployments today are actually still with eigen beamforming. And the call for research is really, can we achieve these higher efficiencies with the same complexity as we are deploying today? So this bright blue zone is really the target zone that we want to shoot for in our research for 5G advanced. But then also comes 6G, and in 6G we start thinking, about these technologies, new 6G technologies in the existing bands, so high band millimeter wave, the mid band where we deploy massive MIMO today, and then also the low band. But we also can expect deployments in new bands. We are all excited already about research about terahertz as the new thing for 6G. A word of caution though, and a lesson learned from millimeter wave, the limited reach also somewhat puts a damper on the massive scale deployment that we still don't see with millimeter wave, except in certain regions. And so terahertz has an even shorter range of communications, where we have 100 meters. So while millimeter wave is for hotspot deployment in dense urban areas, we can expect the terahertz be more a deployment actually than for indoor. And it will start making sense if we then combine it also with the other capabilities, the precise sensing capabilities. Another interesting band is the band just above the midband, the band between 7 and 20 gigahertz, where there's a promise of enhanced capacity from existing cell sites. So that is an important area for innovation to make that happen as well. And then, of course, we can also see further improvements in coverage in the low bands. So this is for the new spectrum technologies. And then last but not least, security. And already in 5G advanced, we will see an increased level of attention for security because of the expanding threat factor. And that is caused by increased levels of 5G, but also more 5G advanced use cases in the verticals, especially in vehicle to vehicle, in the railroads, in manufacturing, where security is also important because it also impacts safety. And there's a lot of information on this slide, how each one of the 5G capabilities and the 5G advanced capabilities, like reduced capabilities, RedCap and slicing, and the radio jamming, all impose security threats that need to be dealt with, and there's solutions there. But the main takeaway that I want to bring here in this slide is that in 5G and in 5G advanced, we typically first defined the capability, and then we started analyzing what are the possible security threats and how do we mitigate them. And the important shift in thinking that we need to do for 6G is that we design 6G security in from the ground up. And in 6G, we will see an even further inflation of that threat surface because of the billions of devices that we're going to connect, of untrusted sources. Also, these millions of subnetworks, again, untrusted networks, open interfaces because of the, in 6G, prevailing disaggregation that we will see. The heterogeneous cloud, we can expect that will be a fairly trusted infrastructure because the web scalers, that's their bread and butter. But then all the software that runs on top of that from different sources, open source as well as different vendors. Then also the use of AI ML as a source of security threats because of adversarial training, but then also as a tool to mitigate potential security threats. So an enormous space of new dimensions and opportunities and threats that we need to analyze for 6G. So before summing it up, here is a reminder of the timeline that we start seeing a consensus in the industry. So this is the well understood timeline of 5G and 5G Advanced. So we are at the moment at release 17. 5G Advanced, we typically see that as release 18 and beyond, where we can expect first specs by 2023 and then commercial deployments by 2025. And then we have 6G, where we started doing the research in many parts of the world. Here in Finland, Oulu University driving the 6G flagship. We have the HEXA-X projects at the European research level. In the US, we have the NSF Rings program and the NextGA run by ATIS, where we do the pre-consensus building, the pre-requirement collection, the first 6G conceptualization. So that will lead to, the conceptualization. That will lead to then the first requirement collection in 2024, the studies, so that we really start seeing a standardization process coming out with a first spec by 2028 and first deployments by commercial deployments by 2030. So in summary, we see these two important thrusts. On one hand, the accelerated investment in 5G enabled ICT. I explained how that COVID was an important trigger there to enable more remote operations, more remote work, and more automation to enhance productivity, efficiency, and safety. And there we can still expect a lot of innovations in 5G Advanced, all to be deployed by mid of the decade, to start by mid of the decade. And then for the 6G era, which is starting in 2030, which is still a decade out, but where it's important to start the research now, and where we have a vision of augmenting the human potential by connecting the physical world, our human biology world, with digital twin models in the digital world to augment human potential, and where we see 6 key technology era that we already see first instances in 5G, new disruptions in 6G to create this essential fabric for the 6G era, the augmentation of the human potential. With that, thank you.
Thank you, Peter, for really broad presentation. There are so many different dimensions to this, and we have some questions coming up in chat. But before that, I would like to warm you up a little bit. Towards the end of your presentation, you were addressing security and trust related issues, which I see as probably the biggest threat for any technology development related to ICT in the future. You didn't explicitly mention anything about data privacy. Could you comment a little bit on that? My claim that if we cannot guarantee data privacy, it's impossible to achieve trust. Can you comment on that?
Yeah, I agree. So especially when we get this massive scale sensing, you will only trust the network if that data is stored in a private and secure way, and only then will you allow that there is a digital twin of yourself, and you also want to make sure that that digital twin is not hampered with, and that I have a fair representation of myself. So absolutely, privacy is key to that as well. And there's a role for also regulation in that space. Absolutely.
Yeah, which is taking place already, I think. There were a few questions, and I'm now going to jump to those. There's one question on role of Wi-Fi, and you did address it a little bit when you talked about spectrum on midbands and these shared 7 to 20 gigahertz band. So definitely there will be role for shared spectrum as well. Am I right?
So absolutely. Well, first, I think the question came up on chat probably at the moment when I talked about the 5G enabled ICT investments. And then, yeah, there are also Wi-Fi enabled ICT investments. And I think there we need to make clear that 5G as well as 6G is more than a radio technology. 5G and 6G are a network a vision and a network architecture. And in that network architecture, you should include also the capabilities of Wi-Fi as a radio. When you create slices, you can have include in that local area network Wi-Fi capability. So that is one. I think we should also, going forward to 6G, keep in mind that probably 6G Wi-Fi will have its own evolution. Wi-Fi is good at low cost. Wi-Fi is good at using the unlicensed band, and there's some steps towards better reliability and low latency. It's maybe not a 5 nines or 9 nines, but 4 9 reliability and decent latencies in the order of a few milliseconds become possible in a, for instance, control factory environment. But what then 3GPP is very good at is coverage and mobility. And so we should see these technologies each as their strengths, also efficiency of the spectrum. And now to your comment on the 6 to 20 gigahertz, it's not only the shared spectrum, it's actually a call for, hey, there is an interesting spectrum there that we should pay attention to and we should make available for 6G, even as licensed band, as opposed to the terahertz that has such a short range. That 7 to 20 gigahertz range allows for interesting deployments with better coverage, even from existing cell towers. And if you can do that, then that will be deployed.
Staying a little bit still in the spectrum issue, you didn't mention anything about visible light communications. Do you see any role for that in your visions?
Only if it can beat the performance of the millimeter wave and terahertz. It is equally a line of sight technique, and you need a solution for automatic beam alignment, light beam alignment. And we haven't seen yet practical solutions for that other than mechanical. And the strength of a radio wave is that you can, with arrays, do an electrical.
But maybe it might have some special use cases like inside aircraft communications, downstreaming videos per passenger, maybe?
True, but so does millimeter wave and radio frequencies. Why would you have them specifically for this niche application, a separate technology? I see more maybe as backhaul technologies between base stations, tower to tower, as it is being used today. But I think the big problem to solve is being alignment.
Okay, let's jump to the next question, which is coming from one of our researchers, Mehri Benis, who is asking from you that, do you have something really revolutionary in your vision, since he says that your ideas are to great extent 5G plus flavored? Can you comment on that?
Yeah. So thanks for the question, because it actually allows me to reiterate the point of the talk, which is we will see early instances of all those capabilities in 5G, but 6G does allow for a clean slate approach. So we as an important example, AI applied to the radio interface, we will see it to improve the certain layers, as I've shown, the front end scheduling. In 6G, we can do a clean slate approach. Similarly,
are there, in your opinion, some specific bottlenecks or challenges that you foresee already now that we as a research community should pay special attention to?
Yeah, so I think since I was talking about AI, I think definitely de-risking that AI, showing how it will reduce the complexity. So that's the claim, how it changes the way we design networks. But not only zooming in on AI, I think we need to have a fresh look at the network at large. So I mentioned a number of paradigm shifts also in the network. The cloudification of the network is an important one. So now it is still on the side. We still have classic radio access networks, but the cloud disaggregation of that functionality will be the paradigm shift for 6G with the better accelerators, and that will change the way we design networks and with microservices create the services, and then enable the new deployment models as a service, just like cloud applications happen today.
Thank you for your answer. Now there's a question about complexity. And the question is that how is it possible to develop low-cost devices for 5G and later 6G to do so many different complex tasks that the devices are supposed to carry out?
Yeah. So on one hand, we should not underestimate the power of the exponential Moore curve, even if it is slowing down. Things that were not possible 10 years ago are possible today. So that is one, that there's an increased level of integration that we can expect, and that will be true for AI acceleration as well. Secondly, I also think 6G is about specialized networks, meaning you have a very complete standard, but then you will instantiate devices specialized for the purpose, and you will select a subset of capabilities for that purpose.
Thank you. Then the next one is about satellite communications, which you did not explicitly touch in your talk. What do you think about the role of SATCOM in 6G?
Yeah, so I think satellite on one hand, like I did mention for 5G advanced, as an enhanced of coverage in areas where the terrestrial network doesn't have the proper reach, in rural ocean liners, airways, so enhancing the coverage, but then also enhancing the reliability. So if there's a failure in the terrestrial network, that you complement that with satellite capabilities. There's a lot of investments in satellites these days, and yeah, once you have that infrastructure in the air, it will be used to the benefit also of 6G.
And for audience, we still have some minutes time, so I'm encouraging you to put forward more questions. And whilst waiting for that, let me ask you, Peter, one thing that we from our flagship are claiming as one possible trend towards the future: increasing role of critical vertical application areas going to change the way the future standards or technologies are going to develop. You touched this a little bit when you talked about cloudification and possibility to customize local networking solutions. But can you go a little bit deeper on the role of verticals in the future technology development? Do you see role of vertical industries increasing, for example, in 3GPP standardization towards 6G?
So absolutely. So we already see it in 5G, and that trend will continue in 6G, where these verticals and industry players start to recognize the value of standardized wireless networks, start bringing in their requirements. So that will definitely go forward. And as I mentioned, with that disaggregation and flexibility of microservices, even have requirements for specialized functions that we can then easily create also on a slice-by-slice basis. And then we can expect them also come in with new application requirements for the sensing that the network will enable.
Now comes probably a little bit tough one. Some people are saying that in order to make future networks serve society as it should, we should really try to foster network architecture development more towards service-centric approach rather than network infrastructure ownership-centric. Currently, we are accessing services offered by our own mobile operators, and maybe in the future when we have a lot of customized local solutions, that is losing somehow the importance. How do you see this type of development of new entrants coming to the play and having, let's say, competing entities compared to current mobile network operators?
So it's indeed becoming an interesting future where we see, on one hand, private network deployments. It's for specialized users in verticals and in enterprises. On the other hand, we see also the web scalers coming up. We see, thanks to that disaggregation, opportunity to leverage their platforms and ubiquitous presence. And then you have the CSPs that come with their strength as we understand how to deploy networks and we understand how to reach the subscribers and the customers. And it's going to be an interesting play how each will try to leverage their strength. And the same is true also for the system vendors, the new entrant system vendors, the web scalers. Each will come from their strength, understanding of the network capability, the software that will run on the platform. The web scalers will come from their angle. So it's going to be an interesting play, but definitely this disaggregation allows for a lot of flexibility and a lot of different possible scenarios.
Now, Peter, it's time to start to wrap up your really nice presentation, and let me ask you, is there a specific wish you would like to pose to a global research community now starting or studying various interesting aspects on 6G?
That's a good one. Think out of the box. Don't be encompassed by what we can already do in 5G.
Thank you, Peter, and have a great day back at your office. So now this concludes our first keynote session, and we can have a few minutes break before starting the second keynote at past. Thank you for your attention.